Hello, welcome back to a new lesson of science class. Are you ready to learn?
Today, we are going to start a new chapter, Chapter 11, Forces. And the lesson is Motion and Forces. So, let's go to pages 482 to 488. In this lesson, you will be able to explain how motion, speed, velocity, and acceleration are related, and also summarize the forces that act on a moving object, including friction and gravity.
Our vocabulary words are motion, speed, velocity, force, acceleration, inertia, friction, and gravity. Let's look and wonder. Do you enjoy running? When you run, you move fast and use a lot of energy. How can you tell how fast a runner is moving? What affects his or her speed? All these questions, we will answer them along the lesson. So, what is motion? Let's imagine you're taking a ride on your bike and your starting place is at point A and your ending place is at point B. This means you change of location. You moved. Let's watch a video explaining more about motion. Ben wants to move the table from point A to point B. He will push it in that direction of point B. You see that as he pushes the table, it starts moving. We can say that anything that moves around us has motion. So this table is in motion and Ben is also in motion because he's moving along with the table. In our daily life, we see different things moving around us. For example, cars moving on the road, people walking down the streets, and birds flying. Let's talk about another important concept in motion, speed. All moving objects have speed. Did you know that the cheetah can run at nearly 112 kilometers per hour? That's an amazing speed. Now, let's see the following video to understand what is speed and how to identify this concept. How do we know if an object in motion is traveling faster or slower than another? Think about two objects, Object 1 and Object 2. Both are moving along the same road. Just by looking at their motion, can you tell which one of them is moving faster? Clearly, Object 1 is moving faster compared to Object 2. This one is behind. So we say that Object 1 has more speed than Object 2. We can say that speed tells us how fast something is moving. But how to define it? In order to know the speed of an object, there are two things we need to know: the distance traveled by the object in motion and also the time that it takes to complete that distance. Sometimes people confuse velocity with speed. Speed tells you how fast an object is moving. On the other hand, velocity describes the object's speed and direction of motion. For example, a train's speed is 300 kilometers per hour, but the velocity is 300 kilometers per hour to the east. Remember, velocity is speed plus direction. Now, how do forces change motion? How many times each day do you push or pull something to make it move? When you throw a boomerang, for example, your muscles push on the boomerang. The boomerang moves away from you. So each pull or each push is what we consider a force. Forces can be big or they can be small.
Also, forces can cause objects to start or to stop moving. Forces can also change the speed or direction of a moving object. Remember the name Isaac Newton? He proposed 3 laws. So we're gonna watch a video so we can understand the concepts of acceleration, inertia, friction, and gravity. Let's start!
Have you ever noticed that it's harder to start pedaling your bicycle than it is to ride at a constant speed? Or wondered what causes your bicycle to move? Or thought about why it goes forward instead of backwards or sideways? Perhaps not, and you wouldn't be alone. It wasn't until the 17th century that Isaac Newton described the fundamental laws of motion, and we understood the answer to these 3 questions. What Newton recognized was that things tend to keep on doing what they are already doing. So when your bicycle is stopped, it stays stopped. And when it is going, it stays going. Objects in motion tend to stay in motion, and objects at rest tend to stay at rest. That's Newton's first law. Physicists call it the law of inertia, which is a fancy way of saying that moving objects don't spontaneously speed up, slow down, or change direction. It is this inertia that you must overcome to get your bicycle moving. Now you know that you have to overcome inertia to get your bicycle moving, but what is it that allows you to overcome it? Well, the answer is explained by Newton's second law. In mathematical terms, Newton's second law says that force is the product of mass times acceleration. To cause an object to accelerate or speed up, a force must be applied. The more force you apply, the quicker you accelerate. And the more mass your bicycle has, and the more mass you have too, the more force you have to use to accelerate at the same rate. This is why it would be really difficult to pedal a 10,000-pound bicycle. And it is this force, which is applied by your legs pushing down on the pedals, that allows you to overcome Newton's law of inertia. The harder you push down on the pedals, the bigger the force, and the quicker you accelerate. Now on to the final question. When you do get your bike moving, why does it go forward? According to Newton's third law, for every action there is an equal and opposite reaction. To understand this, think about what happens when you drop a bouncy ball. As the bouncy ball hits the floor, it causes a downward force on the floor. This is the action. The floor reacts by pushing on the ball with the same force, but in the opposite direction, upward, causing it to bounce back up to you. Together, the floor and the ball form what's called the action-reaction pair. When it comes to your bicycle, it is a little more complicated. As your bicycle wheels spin clockwise, the parts of each tire touching the ground push backwards against the earth. The actions. The ground pushes forward with the same force against each of your tires. The reactions. Since you have 2 bicycle tires, each one forms an action-reaction pair with the ground. And since the earth is really big compared to your bicycle, it barely moves from the force caused by your bicycle tires pushing backwards. But you are propelled forward.
As ice skaters move around, they can go faster or slower. They can turn left, right, or skate in a circle. Any change over time in the speed or direction of a moving object is what we call acceleration. Now, an ice skater will not start to move unless a force acts on her. When moving, she cannot change her speed or direction unless a force acts on her. And this happens because of the tendency of an object in motion to keep in motion, or of an object that is resting to keep resting. In other words, we are talking about inertia. Now that we know that all objects with mass have inertia, what is it then that brings a rolling marble to a stop? Why doesn't it keep rolling with the same velocity forever? The answer is friction. Friction is a force that works against motion. It acts between the surfaces of objects that touch. The surfaces rub against each other, and this will slow down the object or completely stop it. A force is acting on you right now. This force acts on you and me all the time. Do you know the name of this force? Correct. It is gravity. Gravity is a force that acts over a distance and pulls all
objects together. The pull of gravity will depend on two things. Number one is the amount of matter of the object, and number two is the distance between the objects. Objects with more mass have stronger pull. For example, the Earth. Its gravity pulls strongly on all objects, and that is why we keep our feet on the ground. On the other hand, the moon is less massive, so its pull is weaker. Gravity is also stronger when objects are close. If the objects move apart, the pull of the gravity is weaker. Goodbye, my dear fourth graders. Don't forget to like and subscribe.